Okay. Unmuted? Is it on? Okay. Perfect. Hi. Thanks for waiting. I messed with the travel gods too much this week. I will not tell you why I'm late. I will not tell you I got on the wrong, in the wrong direction, the tram, because I've not been this stupid in a long time, and I've not fucked up twice in a row on 2 days this bad. And now seriously, I apologize. I don't want to keep you guys waiting because there's other cool talks that are also very good. So we're running a little bit late. I think the session, the slot's until 30, so I'll have to rush a little bit. This talk is called Surviving a Primetime TV Commercial. It's mostly about lessons learned, general overview of how a few things we approached. There's not going to be a million lines of code telling you how exactly to, because this is not the detail that is critical in such a situation. The code that you write will not make the big difference in whether or not your site collapses under the load of TV ads. It's more the architectural choices you make up front, right? And a development process that you need to get there to be able to test things before the big TV ads run. My name's David. I have an umlaut in my name, which indicates that I'm German. I'm from Munich. That is a city in Germany. We make really good beer. I work there as lead architect of a company called European Media Holding, or rather for their technical incubator, and we do e-commerce ventures. So I get sent to all these companies, solve a lot of business problems. In this case, I'll explain in a moment what it was in this case. And I work with our engineering team that provides implementation to these ventures to build, for instance, an e-commerce platform and a shopping website. This is me on Twitter. So you can berate me for being late and unfollow me for being late. Follow and unfollow me. So the challenge that we faced was this. It's a website called Kivida, and we try to sell kitchens online. It's actually working. A lot of people for a long time said, you can't do that. So maybe for those unfamiliar, I think maybe people from the UK, in particular people from the United States or Canada, when you rent an apartment or buy an apartment or buy a house in Germany, there's usually not going to be a kitchen in the room where there's supposed to be a kitchen. It's an empty room. So you go to IKEA or you go to another store and you buy one. You either assemble it yourself, in which in case of IKEA is really tedious because you also need to assemble the individual cabinets. So that takes a long time, is really frustrating, and there's always parts missing. Or you get professionals who bring the thing to your home, assemble it for you, which usually costs quite a premium because it is a tedious job and there's always parts missing. So what we're trying to do is sending standardized ones off the website, and you can also have salespeople come to your house in a little car, and they will discuss things. There's other features that we're going to be where we're going to be trying lots of automation. For instance, a man comes into your home and he has a laser, and the laser is put in the middle of the room and will then scan the dimensions of your room, exactly where the electrical outlets are, where the water supply is, where the windows are. And then someone in the sales department can plan a kitchen that fits exactly into your room based on these laser measurements. So that works, and we ran this for quite a while using an off-the-shelf e-commerce solution. In our case, it's Oxid e-cell, so it's not Magento or something like this, or Shopware. It's Oxid, which is relatively popular in the German-speaking region of Europe. And the challenge now is we want to run TV ads during primetime hours, which means about between 8 and 9 p.m., maybe on a Sunday night when people have time, people are not out drinking, a big blockbuster is running and they're sitting on the sofa, and nowadays people have their tablets with them and the laptops. And that means that in case of Germany, within seconds, or at most a minute or two, you will get about 10,000 concurrent visitors who produce a lot more hits on your website. And if you try and do that with a standard software such as Oxid, you can't count to 3 until the error site comes on, and then you can count to 3 again, and then everything's white, because at some point it'll just be a lot of different factors that will take the site down immediately from this stampede of users. because a lot of them will also be clicking around in the configurator, trying to put something in the shopping cart. But most people actually just go to the front page, which pulls CMS content from 10 MySQL queries, and then people click around in categories, and then they start sorting things in descending order, and all of a sudden there's an unoptimized index somewhere in this database. And from the requests that come in per minute, it'll spike up like this. This is a dramatization, and the numbers are completely made up, but roughly like this, right? And the question then is, what's going to happen first, right? Is Apache going to be eating up all your RAM? Are you going to be running out of MySQL connections? Are you going to be trashing I/O on the disk to the point that the load spikes up on the server so severely that everything stops, grinds to a halt, and the load balancer decides the backend is unhealthy and starts serving error pages, and basically you're screwed. But the good news, so this is a thing that actually helped us in our particular case. The good news is TV ads during primetime TV hours don't happen suddenly and surprisingly and unexpectedly. They happen actually at a predetermined time. We know within a couple of, plus minus a couple of minutes, we know exactly when it's going to air. So theoretically, we could prepare it. We could pre-generate everything statically or something like this. So this helps. You still need to make your thing scale, not web scale. That's MongoDB, and that wouldn't help you. But it's probably just going to crash and lose your data. So I hate MongoDB. I shouldn't be so mean to them. Okay, so anyway, options for scaling out. So you have basically two options in such a scenario. You can that was on video. It was on video that I don't hate MongoDB. MongoDB is amazing. Okay, so you can add hardware and caching solutions. So for Magento, for Shopware, for Oxid, there are actually hosting companies who have specialized hardware configurations and their own custom caching proxy solutions, usually a lot of varnish and a few extensions and a few patches for the solution. But they don't release that for purchase or even open source. They give you that if you host your shop with them. And they charge a hefty premium, but they're also experts at this, right? So they make sure that your standard e-commerce site with a bunch of plugins and customized templates and maybe different payment providers stays online, and they manage that for you. So the problem then is that if you do customizations, you still have to deal with the great code in the software, right? Because these are old solutions. They've been written quickly by someone who ever started a shop and then thought, hey, maybe I could sell that software and open source it at some point. So if you've ever looked at the code of legacy shop software systems, it's not that pretty usually. And you have recurring license costs, right? So per server you pay, plus maybe the caching solution. And one important factor for us was so Kivita is one of the e-commerce things we do. There are other plans for the future for other shops, right? So we would have to pay the license costs again for the next shop system that we built. So we would have to pay these license costs every time, and that adds up. Or the option B is you could build it yourself. You invest up front, obviously, right? And you need to maintain it yourself. But what we actually did was use a hybrid approach where we say anything that the user faces immediately after going to the website. So front page, the categories, search, product details, stuff like this, we will write again ourselves. And anything that is about payments, the shopping cart, recommending a product to someone else, for that we use the old existing software, because the last thing you want to do is spend most of your development time trying to integrate payment providers and stuff like this. This is like really, really horrible stuff. Logistics integration, CRM and ERP synchronization, right? How do you make sure that we actually know how many kitchens are in stock, etc.? This is something that these e-commerce solutions are actually reasonably good at. Plus, there's a whole ecosystem of third-party software that connects to these solutions and figures out how to do your CRM best, your ERP, how to make sure that your credit card payments go through, and things like this. So we went with this approach, obviously, because that would be boring then when the talk would be over now. And we had a few goals. These goals were, some came from the engineering team, some came from management, some came from my CTO, who had sometimes completely ridiculous ideas. They were not really realistic. But one thing we wanted to do was serve the homepage, product detail, category browser, search under load in under 100 milliseconds. One engineering goal was we would like to degrade but not fail under extreme load. And we would rather trail staleness slowness over, partial failures over slowness. So maybe degrade features, remove a feature, like don't show something instead of making the experience slow for everybody. And also trade freshness of information for performance if it was necessary, or in case of errors, meaning something is going wrong, then we would rather show maybe an outdated price or an outdated availability information, right, instead of showing an error to everybody. Because it's just not as bad a user experience if you see some price and you think, oh, maybe that's a bit expensive, and then you go shop, then you keep browsing for something else and buy that maybe, rather than seeing an error. And one important thing that you need to keep in mind is if it's a primetime TV ad, people will usually sit on their sofas and they will see, hey, new kitchens, etc. And then someone thinks, hey, I wanted a new kitchen for a while. My kitchen is annoying right now, so let's see what that costs. And they will go to the website and browse around a little bit, but only a fraction of these people will buy something, right? Oh yeah, and anytime we make a change in product database, it should be in the front end in under 60 seconds. And one thing that I just decided for myself, and everybody was happy with that, or didn't complain about it, was I said, we're using this standard e-commerce solution for checkout and for the purchase process itself. So if we ever have that many users that, the TV ad is so successful and we have such a great deal somewhere on the website that so many people buy things at the same time that that old software will crash under the load of purchases, then we will not worry about that but open a bottle of champagne. Because that's a really good problem to have. Like you just, because that usually doesn't happen. As I said, it's a fraction of users that will buy something. Most will just browse around. And in particular, kitchens are relatively complex products, right? It's not like shoes or something really, really trivial where you can quickly decide whether or not you like them. For a kitchen, you have a myriad of configuration options where you can say, I want the doors in red or in blue, I want these sort of knobs or pulls, which sort of electrical appliances do I want? Do I want the expensive or the cheap fridge and stuff like this? So if people come to your website, it's a spike of load immediately as they start browsing, and then once they start settling for something, you get a relatively long tail of requests that even out over time. So you don't need to worry about that so much. So in our case, this type of product we were selling and how we were selling it actually affected a few architectural decisions, so that, for instance, we wouldn't have to worry about this part, right? Because this is for the stuff we sell. If you have a live shopping portal, for instance, right? You know these things where you have a deal for 1 hour, it's that price. Then people will rush to your site and they will purchase it. So then you can't open a bottle of champagne. Then you actually need to fix it, because that's exactly how you make money, right? They have 60 minutes to buy these loudspeakers at this fixed price. In that case, you will get an influx of users, you will get big spikes in load, and you will get the purchases. So then you can't say, oh, I'll just let this other software handle that, and hopefully it'll work, because that will break down. So we wanted a share nothing architecture, or at least share little. So individual components don't necessarily communicate with one another. You could at any time bring up or down a web front end, for instance. Failover configurations where needed, so anything should be fault tolerant, at least to the extent where it's financially reasonable. Full text search that can also withstand, let's say, 10,000 searches within a couple of seconds or something like this, right? Because search and giving good recommendations, related products, stuff like this is actually relatively important for an e-commerce website, because people click around and they don't really like what they see, but if there is something similar they see recommended, maybe they will buy that. So that is important. And ideally, we said, hey, ideally we don't even hit the app server. This is where varnish obviously comes into play, right? But it's actually not that trivial. Then for us, another question was traditional hosting or the clouds. Do we host everything ourselves? Do we use only software as a service such as S3 and stuff like this? Do we put parts on EC2 and parts on traditional self-hosted hardware? Or do we have everything in the cloud? Option number C, you can forget that. You will have to deal with data replication issues, latency. So for instance, we thought, we went from B to C to B. B initially was because the CTO said he doesn't want to host anything on Amazon. Then I said, but I want to use S3. Then I fought with him for weeks, and then he said, okay, because he doesn't trust them or something. No, it was fine. So we discussed it a little bit and ended up with option B. And then one morning, I get this requirement saying, at any point in time, I want anything to be scalable into the cloud to deal with load. And I said, no. Because, we thought about actually making it work for a while. Spoiler, we're going to be using Elasticsearch. So we thought about, hey, could we maybe do that? Elasticsearch actually has features for running on EC2 across availability zones, and then it'll take care of correct sharding and correct replication behavior within and across the zones. But ultimately, the problem you deal with when you try to do that, even if we said, for instance, we want just the database, so the checkout process, etc., runs on our own hardware, and any code that just shows category, start page, product details, search runs on EC2, then you still have the problem that as you bring up instances on EC2, you need to start replicating to them, maybe from your own hardware into the cloud. So you deal with a lot of delay for replication. You can't provision within seconds, probably not even within minutes. If you try to get Elasticsearch to replicate its data over a WAN connection, because it's not local network, right? You send stuff across the internet from somewhere in Germany to somewhere in Dublin, maybe. You have latency issues. So if you then want to make a query from the front end to your database, it goes over thousands of kilometers, and even at the speed of light, this is going to incur some delay, right? Connection handshakes between parts of your system. So we said, okay, let's not do that. There are sometimes options. So you could, for instance, always say you would like to use Amazon's Direct Connect. This is AWS Direct Connect. Basically, gives you a direct line from wherever or from a point of presence somewhere in Europe, for instance, into the Dublin data center or somewhere else. That cuts down on latency, but you need to pay a lot of money for gigabit or 10 gigabit connections. But if you ever need to do that, so you need to marry your local data center to the cloud, use Direct Connect. Anyway, so we used Symfony because that delivers. It's great. It has lots of bundles. The community, it's easy to get talent. It made absolute sense because parts of the engineering team were familiar with Symfony 2. And also, because it makes things very, very future-proof. It has all these features for caching built in, etc. Special mentions maybe that came in powerful for us or useful for us. The Symfony's bundle inheritance was really, really useful for us because basically we built an abstract shopping website with base functionality in bundles. So you can list products, you can list categories, you can browse categories and stuff like this. And that works using basic wireframe, not with a nicely designed website, but it works. And then, for instance, this Kiveda website overrides templates and parts of the code for their own special needs. And this makes it possible for us to centrally maintain the base functionality, scalability, performance, reliability, backups. Deployment is always unified across all shops. But then the individual shops could have their own engineering teams. Right now they don't. It's all done centrally. But they could have their own engineering teams who basically use a license of this shopping software, of this fast front end. We call this Fox because foxes are small and nimble and fast, and because it's a faster version of Oxid software. So, not my idea, but yeah. So there we have the base implementation, and the sites override templates, sometimes even controllers and stuff like this. This was really, really useful in how we organize the software. And each bundle is its own Git repository. Everything's managed through Composer. So the website is basically just pulls in like 20 bundles through Composer from GitHub. And some of these bundles are then overridden. And Twig was really, really cool for us because it allowed us with a new version of Oxid to actually share parts of templates between the shopping cart, like at least the master template with the main design, etc. That was really useful. So, because Twig has widespread support across the world now, and that made it really convenient for us. So at least some template sharing we have, plus the designers who design templates and work on them, they only have to learn one template language for both the fast front end and the slow checkout and shopping cart part. Elasticsearch already spoiled that. You could also use Solar. At this point, it doesn't really make any sense. When we started out, Solar 4 wasn't that ready yet, which has all the cloud and clustering features. We use Elasticsearch not just for search. It's actually our complete database, right? All product descriptions, all the information we need, all pricing, availability, we put in there. So if you look at a product on the website, it's not going to look, or you perform a search, for instance, on the website, a full-text search. It's not going to pull product IDs from there and then talk to the old MySQL to figure out availability and pricing. It actually reads everything it needs from Elasticsearch. So the front end never hits the original MySQL. We replicate everything in there. More and more people start doing that with Elasticsearch and with Solar, because they used to be just full-text search solutions. But they're so capable, and Elasticsearch in particular is pretty easy to scale. It always has there's always edge cases where sometimes you bring up a few nodes, bring them up again, and down and up again, and then replication goes a little bit crazy, and things like this, where you sometimes need to be careful not to saturate your network or during writes have bad read performance. But that's just usually a matter of optimization and configuration. And the other really, really great thing about Elasticsearch is that it has distribution and high availability and durability built in on the software layer. So we don't need expensive hardware with expensive RAID controllers and redundant power supplies. So we have 2 beefy boxes for the MySQL, right? And then 2 simple, actually we run 3. 3 really simple, relatively cheap servers with not a lot of RAM, not that much RAM, standard disks, no RAID, no ECC RAM, no redundant power supplies that power these web front ends. Because they all run Elasticsearch. Elasticsearch makes sure that there is replicas of the data. So if one of the servers dies, we'll just replace the hard drive and let it catch up again. We don't have to invest in more expensive hardware with RAID controllers and stuff like this. And this is a general trend that we're seeing. It's basically the same in the cloud, right? Any instance on EC2, you need to be prepared that any instance that you run could disappear at any second, or at least you should design for that. So more and more solutions that we see for databases, etc., take care of all these durability and high availability features for you on the software layer. And ultimately, this means that running things is just getting cheaper and cheaper and cheaper. I mentioned the same thing yesterday in my Hadoop tutorial, which is basically the same principle there. Do it on the software level, and then you don't have to worry about specialized hardware. Now we had to replicate from MySQL to Elasticsearch. There are several options. You could pull the data. You could pull the data in regular intervals. Elasticsearch actually has a plugin. I forgot the name for that. That can pull tables with certain queries. We actually decided, we don't really want that because we don't want to incur any sort of read load on the database servers. You could also do it in your application. So, for instance, if you use Doctrine, you use certain triggers, right? Callbacks of listening to certain events. That will then also write the data to Elasticsearch. That, of course, has the problem that you need to use Doctrine everywhere, and Oxid doesn't use Doctrine, so we didn't have that option. We actually used triggers in MySQL on the tables that we wanted to replicate, and every time something happens there, the complete record is just written out to an append-only, basically, log table. And then we have a daemon running. It's a Symfony's command line script that runs every 60 seconds and reads everything in this replication instructions table and replays all these changes sequentially into Elasticsearch. Right? We use supervisor-D, so if you ever need to run things periodically and want to make sure it keeps running and want to see quickly when it's failing, don't use cron. Because cron, maybe you can do monitoring, etc., and try and figure out, read logs, etc. But usually, figuring out that a cron failed works like this. Things work, things stop working. An hour later, someone starts noticing that things stop working. You log into the server, and it says, you have mail. You type mail, and you get 5,000 messages already from cron saying it can't invoke the script because. So supervisor D is really cool because it keeps stuff alive. You can tell it whenever a process exits, automatically restart it. If it fails to restart more than these n number of times, please notify me, send an event, redirect any errors to certain logging facilities. You can say, if things start longer than so-and-so many seconds to run or start up, then notify me. So monitoring your recurring scripts, your background tasks using supervisor D is really, really easy. So what we do is we have the script that goes through the table, and once the table is empty, so all instructions have been processed, it'll actually exit. Well, it waits 60 seconds and then it exits. The idea for that is that supervisor D will restart it for us, and then because it's PHP, I don't want to worry about memory leaks. Like we use with lots of doctrine, etc. I'd rather not have that running for 5 days, right? So we exit, and supervisor D makes sure, boom, it's automatically restarted for us. And this will also, for instance, send purge commands to Varnish. So it sees the product has been updated, figures out which one that is, purges the cache and stuff like this. This runs on one box sequentially, right? It's monitored properly. There's a failover configuration in case that machine fails. Another is promoted to master, and then that will run the supervisor D thing. And because it all goes to the same database, we have a master MySQL setup, so there is no chance of data loss. One thing you can't do usually, or is very difficult to do, is using something like Gearman to speed things up in parallel. Because what could happen is that a write comes in to create a new product, immediately followed by an update, and then if you have different workers for this or something, and the queues have different lengths in Gearman, then maybe all of a sudden the write that updates the product with a new price actually gets sent to Elasticsearch first, and then after that, because it was stuck in some sort of queue, or simply because it ran slower, or simply because of network latency, the task runs that creates the product. And all of a sudden you have the product in Elasticsearch, but the price update never applied because that came first. Right? So keep that in mind. Parallelizing things such as database replication. There's a good reason, for instance, MySQL. MySQL replication runs every query sequentially, which actually can be a big problem. So I've had cases where we had write loads on the MySQL that was so bad that we could not replicate that over a gigabit Ethernet connection, because there were so many writes into MySQL, and a lot of these happened in parallel, lots of triggers, store procedures, etc. And the replication to the MySQL slave happens sequentially. It sends one query after the other, and it would just never catch up. Well, sometimes during the night when the load was slower, but during peak hours, sometimes it was 1, 2, 3 hours behind the master, which is pretty drastic. Okay. Now, more things you should always try when doing things that should scale, things that should sustain load. Cache everything, or at least whatever you can. Varnish, obviously, right? Always use Grace and Saint modes properly. Takes had a really nice workshop yesterday. I hope some of you attended. And you would say, done, the problem is solved, right? Usually, yes. In case of an e-commerce website, obviously people have shopping carts and they might be logged in. So you need to cater for that. So you can't cache the complete page. You have a couple of options. You use edge side includes. So you have an include block somewhere in your cached page that says, give me the shopping cart fragment that just says what's in the shopping cart, how many products, and what do they cost. And that will hit a backend. That might slow down things for everybody, but at least the main content can be cached. Option B is you make an XML HTTP request after the page has been loaded to figure out what's in the shopping cart, right? But that makes things flicker. Like the page loads, it says €0, and then all of a sudden it changes. And over a slow network connection, it confuses users. And you even run into cross-origin requests problems with HTTP versus HTTPS and stuff like this. Or you use signed cookies. We had the course problems for other XML HTTP request issues. So Because at some point we face the decision, how do we actually make sure that the correct requests go to the front end, the fast one that we wrote, and how do we make sure that the request to, say, the shopping cart hits the old system, which actually runs on different hardware. There is a bunch of solutions for that. You could do it somewhere in the load balancer using certain URLs, URL prefixes, etc. We ultimately decided to segregate the traffic by protocol. So all HTTPS traffic goes to the old shopping system, and all HTTP traffic goes to the new front end. So once you put something in the shopping cart, that hits HTTPS, so you go to the old system. And we obviously redirect some parts based on URL from HTTP to HTTPS or vice versa to make sure that an attacker, for instance, couldn't bring down the website by simply prefixing every URL with HTTPS. Or you could use signed cookies. That's another alternative, and then all the data lives on the browser only, but then you don't have it maybe in a database that you want on the server side. If you want to use ESI for the shopping cart, the trick we used or did use is you set a marker cookie when adding to the cart. So I put something in my shopping cart, and then you just set a cookie that has a certain lifetime, let's say 6 hours, and this cookie will then indicate to the system when the browser makes another request. The system knows, that user has something in the shopping cart, which is good information to have, because in the next step, when the page that describes the product, right, you look at a specific kitchen or a pot or a pan or forks, I don't know, has an ESI to the cart. But what you do now is, if the cookie exists, you hit the backend. So you resolve that request, maybe to a different backend. We did this in VCL. And if the request, if the cookie does not exist, we simply we did this in VCL fetch, we rewrite /cart to /cart empty.html or something like this. And that always displays €0. And this is a static document, has the correct cache control headers, so Varnish will not hit the backend or hit any server to retrieve this website and replace it in the contents of the website. It will simply say, that's in the cache, so I don't need to make another round trip. That's pretty fast. The same thing we do for logins. You need to be careful, though, with edge side includes, because they have one big problem. They are processed sequentially by Varnish. So if Varnish pulls something from the cache, and this document has 6 edge side includes, it's not going to call them in parallel. It's going to go through them sequentially. So at some point, adding a lot of edge side includes to your website is actually going to make it slower. We also automated everything. That turned out to be extremely helpful, because we have the production environment, and then we have a very large server that runs a lot of Linux containers in the exact same configuration, as in 2 database servers, 3 web frontends, and stuff like this, as production. And we have 2 of these. So we have an unstable staging and a regular staging system. The unstable gets automated deployments. Every time someone pushes something to GitHub, it ends up on the unstable website. And every time someone decides we would like to prepare a release, it gets sent to the staging version. And these, like the live system, have redundant web servers, 3 Elasticsearch instances, so we can make sure that we don't run into magic or unexpected replication issues in production later on. These also use the same hardware load balancers as production, simply to make sure that, because we could misconfigure something in a HA proxy instance for staging, but that's not a good idea. So you want to mimic your production environment as closely as possible. Deploying is done using Capistrano, including rollbacks. And all the servers are provisioned using Puppet. You could also use Chef, for instance. We use Puppet. So the whole machine, from the ground up down to the individual configuration of web servers, etc., is done with Puppet. And that allows us to bring new boxes and staging environments up really, really quickly. As I said, make sure the number of logical nodes is as closely as possible to production. If you have a hardware load balancing, run your staging traffic through the hardware load balancer, because sometimes these things have bugs and you want to catch them before you go live. And one other thing, because we automate so heavily, and including the provisioning is automated so heavily, our development environments are actually vagrant boxes or vagrant definitions using VW boxes. And we use not the exact same, but derived from the production Puppet or chef. You could use chef recipes or manifests to give developers virtual machines that are pretty much exactly configured exactly the same way as staging and production. And on development boxes, it's just one web frontend and one database server. But you could theoretically, in the Vagrant file, just add 2 more boxes, right? Or 5 or 10, and then a developer on their local machine could theoretically, provided that he has enough RAM on it, quickly test how does the system behave with 10 web frontends. And another benefit is what happens if one of the 2 database nodes goes down? What happens if one of the 2 Elasticsearch nodes goes down? Does part of the error recovery automation that we wrote for production actually work? We can test it on staging as well. We can run a load test on staging, and then we say, okay, another 5 front ends with Elasticsearch, wait for them to replicate, and then run the load test again. Or bring up 5 new instances of Elasticsearch, and while they replicate, run a load test. What happens? Does the system fail? Does it just go slow? Is there going to be permanent errors that we need to fix? And in the future, we're actually going to be running the staging environment using the Vagrant LXC plugin. LXC is Linux containers. It's a virtualization technology built into the kernel. The idea is that developers can actually log into the staging environment and kill individual instances and stuff like this and don't have to talk to DevOps people. Right? That would be the idea. A few other learnings: measure everything, log everything, test everything you can. Profiling is important with XHProf. Not like the Symfony debug toolbar, for instance, gives you a quick idea of whether things are slow or not. But if you actually want to figure out where in your code stuff is slow, XHProf is really useful, especially because it allows you to compare 2 runs. So you make a change, run again, and you can compare. This is something I had to tell the developers many, many times until they got it. Because one point I showed up, and they were really proud. They said, we wrote this PHP extension, some parts of the doctrine serialization for the replication are really fast now, and it's amazing. And I said, why? Did you measure how many times is that called? Is it actually relevant? Is that 1% performance boost? We don't know. It's just cool. Yeah, that happens because I spend most of my time. I'm supposed to be architecting software. I'm actually worrying about things like you get a kitchen delivered to your home, and one of the cabinets has a scratch door. Do we just replace the door? Do we replace the door with or without hinges, or the whole cabinet? Do we send someone in person to fix it for you? Can we ship the door? Can we ship a handle for a drawer, or do we have to send 2 people to carry the handle and attach it to the drawer for you? Stuff like this, business process things. But my engineering team is pretty good. I'm really proud of these guys, and they did a great job. Sometimes, as developers do, if you leave them alone for too long, they will veer off the path and start writing PHP extensions to fix problems that we didn't even have. But they're great guys. I love them, and it's actually really good for me that I can trust them so much that I don't have to nanny them every day, because then I can focus on other things. Log any errors, performance metrics, how the flow of your user to your system. Maybe use 2. We use Econda and Google Analytics. And keep this data around. You're going to be so glad that you know everything about your users, you know everything about performance characteristics, that you logged 5 years worth of errors if you ever need to start debugging problems that you didn't realize you had for months. We caught the most ridiculous situations because we log a lot of things. And give your developers access to this data. There's no point in having data and your developers can't use it, right? So my engineers, they have access to very detailed user activity and activity logs and access logs. And they then wrote, for instance, Siege and Sung scripts to simulate network traffic. And then in case of Siege and Sung, it's pretty cool. Either you use MicroArmy or you use bees with machine guns. This was, I think, written by the Obama campaign in 2008. So bees with machine guns and so MicroArmy spins up a lot of EC2 micro instances and runs Siege on these and just creates traffic to your website. And bees with machine guns does the same thing, except that it's bees with machine guns, which is a lot cooler. Outsource everything that you find tedious, right? Don't hold yourself up with problems that you don't really want to have. Storing stuff, backing up. We put all assets, everything into S3. Like it's my personal credit card, runs everything we have on S3. We use CloudFront, we use S3. It sells me a couple dozen euros or dollars every month, which is nothing. It's so cheap, and you get so many benefits. CloudFront as well for content delivery. It's just a lot faster. You don't have to have at least two servers running somewhere on your network where one stores images and rsyncs or NFSs them to the other box, and that's always going to fail. Like every single time ever I've had any asset storage anywhere, one morning the phone rings and says, fuck, the NFS died, what's happening? Oh God, the rsync processes are being too slow. We're having issues, we're uploading something, and sometimes, because the load balancer sends it to the second node and the data's not there yet, none of this you have to worry about with S3 and CloudFront, Cloudflare, any of the other hosted CDNs. Transactional email was another really important one. You want to make sure your email arrives if you send order confirmations, etc. in particular. And systems such as Mandrill or Postmark or SendGrid, they do the delivery things for you. DKIM signatures, sender policy framework records. They make sure that your stuff doesn't end up in spam filters. There's a really curious thing. Some of these have REST APIs, which is ridiculously stupid for sending email. Because what you need to do on your system is you need some sort of email sending queue that somehow feeds into, say, Gearman, which then in the background makes calls to this REST API to send out email. If you do that, then you can just host your own email. It's like, that makes no sense, right? But most of them, actually Mandrill, for instance, that's why I like it, focuses heavily on their SMTP interface. So all you do is you run a send mail locally on every computer, and that has a smart host or some sort of relay setup. So basically all email that you deliver through the local host SendMail or QMail or whatever is relayed through one of these services. You just have to provide username, password, or whatever keys they give you. So the benefit of that is your local code, when it sends an email from PHP, is still very fast because it just connects to localhost, immediately SendMail there immediately accepts it and returns. So it's fast. But then SendMail, which has been under development for 155 years, I think. That's how old email is. And queues it up, buffers it, makes sure that if it can't reach Mandrill or Postmark or SendGrid, tries again automatically for you. You don't have to worry about anything. And these give you lots of statistics, bounce rates. You can look at the outgoing emails. They do click tracking for you. It's really, really useful because you learn a lot about your users. Log stuff, ideally not just locally, but if you quickly want nice dashboards, stuff like Logly or New Relic in particular, it costs a bit of money, but the funny, nice graphs you get are really, really amazing. So that would be the end. The quick summary is the largest primetime TV ads haven't aired yet. They're going to be airing in the next couple of weeks. The smaller ones we've survived without problems. Without varnish in front, so because we can switch varnish off in our system at least, we're seeing response times with about, I think, 2,000 concurrent users of about 140 to 150 milliseconds. And that's mostly because Elasticsearch is amazing. We also have the very specific luxury of not having a large catalog of products. We don't have millions of kitchens. We just sell hundreds of them and then accessories. So that helps with tuning Elasticsearch and having a fast Elasticsearch, but still. And with varnish, it's in the sub 100 milliseconds range, so mission accomplished. And I guess if under the primetime TV ads we will collapse in a couple of weeks, I will send an angry tweet out to the world saying, damn it, my stuff didn't work. And then you'll know. If not, you can just safely assume that these recipes worked for us. So I think we're 10 minutes over time. You can still ask me questions or come here later if you'd like to discuss stuff. If not, thank you so much. I was on Joined In. Please don't remove too many stars for me being late. And if you have any questions, you can also email me. So yes, that was that. Thank you.